In this video, we're going to talk about hypothesis testing for correlation. When we do hypothesis testing for correlation, we talk about degrees of freedom, and we're going to define what that is for correlation. And we're also going to use the R distribution table or the Pearson table, which is located right above this video. If you don't have it downloaded, stop the video, download it, because you're going to need it while we're doing the learning checks. So hypothesis testing with correlation is very similar to the other types of hypothesis testing we've done, in that we're making a hypothesis about a population based on whatever sample we have in front of us. So in a two-tailed test, this is the notation. The null hypothesis would be rho equals 0. Remember, this is the Greek symbol for R, equals 0, meaning that there is no correlation. That's the null hypothesis. On the flip side, we have the alternative hypothesis, which says, yeah, there is a correlation. And that means that it is greater than 0 or less than 0, but there is a correlation. The correlation is not equal to 0. We can also have a one-tailed test with correlation, and you can imagine that if we have a pretty good idea in which direction our correlation is going to be, we might do that. But we're not going to actually be doing that in this class right now, but that is the notation for the one-tailed test. Correlation uses a critical value to establish a critical boundary of sorts. You're going to use this Pearson table, and it's only going to ask you to provide the sample size and the alpha level. And from there, we're going to come up with a critical level. Degrees of freedom for our correlation hypothesis testing is n-2. That's a little different than you're used to, so make a note of it. It's n-2. And again, if the null hypothesis is true, our correlation should be near 0. Let's take this one out for a try. A researcher obtains an R of 0.395 for a sample of 18 individuals. Does the sample provide enough support to conclude that there's a significant correlation? Use alpha 0.05 and a two-tailed test. So the information we need is alpha 0.05 for a two-tailed test, 18 individuals. If we have 18 individuals, what's our degrees of freedom? Let's take a look. If we have 18 people in our study, that gives us 16 degrees of freedom. And we talked about it being a 0.05 two-tailed test. So if we draw an imaginary line between these two spots, we get a correlation of 0.468. So that means that our correlation needs to be 0.468 or above in order for it to be significant. Well, our correlation was not. Our correlation was 0.39, which is less than that critical correlation we found in our table. So we say the probability is greater than 0.05. We fail to reject the null hypothesis. The sample correlation is not in the critical region. Let's try another one. A researcher has a correlation of 0.398, a sample of 25 individuals. Does the sample provide enough support to conclude that there's a significant correlation? We're going to use alpha 0.05 for a two-tailed test. Okay, keep this correlation in mind, 0.398. We need to be that or exceed that in order to be significant. So our degrees of freedom are 23. Two-tailed test at 0.05. We draw an imaginary line. It's 0.396. Okay, our correlation was 0.398. Our correlation is higher than the level of significance. Our correlation of 0.398 provides a less than 0.05 chance that we would find our finding if the null hypothesis were true. In other words, we reject the null hypothesis. The sample correlation is within that critical boundary. Now you notice that the critical boundary in the last one was 0.396, and R was 0.398. That's where it shows it's sometimes going out to the next decimal place provides good information. All right, I'll see you at the next video.